Welcome to JC Connect. Yesterday we were discussing about the different tests on the cement concrete. The different test on cement also we have discussed, and different test on the concrete also we have discussed. In the concrete, the strength is very important characteristics. So in that strength, what is the compressive strength and how they are going to conduct it, tensile strength, how they are going to conduct it, bond strength, how much they are going to conduct it, and the shear strength, how they are going to conduct it, that we were discussed in the previous class. Today we'll discuss the different test on the aggregates. So normally the aggregate is filler material, um, um, along with your sand and the cement, and it is derived from the rocks. um, it is a main important component of the body of the concrete. It reduces the shrinkage and of course affect the economy of the concrete also. Then occupy 70 to 80% of the volume and have considerable influence on the properties of concrete, and it is very important to obtain good quality of aggregates. It is not chemically inert, means it will not take any part in the chemical reactions. It is chemically inert material. Inert material is nothing but it is not going to take any part in the chemical reactions. It is chemically active by inhibiting the chemical bond at the interface of the aggregate and cement paste. Of course, why? Because why I'm telling is that you put the aggregate, make a cement concrete, then after around 1 or 2 years, if you open that aggregate also, the aggregate will remains the same. So then it is securing volumetric stability and durability. It has its own importance in securing the volumetric stability, that is very important, and the durability. Normally, you may ask in this way, corrosion of the rocks, have you seen? No, it's not possible. Normally it is not possible, because normally what will happen is that the durability is its highest property, just like your sand. um, uh, when it comes to the durability aspects, the durability of this aggregate is the first priority. Next, the second, sand. Then of course cement, it will not be durable. Even if you expose it to the atmosphere, normally you lose its strength. Then main classification is, it is broadly classified into two categories. The first one is the fine aggregate. So the fine aggregate is greater than 0.07 mm and passing through 4.75 mm. So then um, the coarse aggregate, it is retained, this is very important, it is retained on 4.75 mm sieve, and it is less than 80 mm. Normally that we can call it as a coarse aggregate. Normally this coarse aggregate has its own importance in um, um, the roads. Normally, when you are constructing any of the roads, we'll use a different size of aggregate. That is, initially we'll use it as a subgrade material, then we'll use it as a sub-base material, then we'll mix it on the concrete with uniform size or the graded size in the concrete. Normally when you are using in the concrete, normally graded size of the aggregates is very important, and saving is very important. You can see in this picture, based on smaller size to a bigger size, aggregates are available in this picture. You can see that the coarse aggregate, on the left hand side you can see that it is a natural aggregate, and on the right hand side you can see that it is the artificial, means it is a man-made aggregate. Man-made means, of course man-made means from the rock itself they have cut it into pieces in the cutting machines. but the left side you can see that the pebbles they are naturally available. Of course the pebble has its own importance in nowadays, due to the shortage of this aggregates, artificial aggregates. Many peoples are doing the research on the natural pebbles and its strength on the various applications. So, main classification on the basis of the geological origin, that is natural and artificial, on the basis of size, it is all in aggregate and a graded aggregate. Means all in means it is a mixed one and it's a graded one. All in means all size of it will be available in the bulk of materials. Graded aggregate means it is uniform, like graded means 10 to 20 size, 20 to 30 size, 30 to 40 size, like that it will be graded. Then on the basis of the shape, it is the angular aggregate and a flaky aggregate, and on the basis of the unit weight, that is the density. Normally we can call it as a weight density. It is not like the mass density. So it is normal, heavy and lightweight aggregates. So natural aggregate, it is obtained by crushing the rocks and also by weathering action, natural agencies of rocks. Most widely used are igneous rocks, and of course no need to explain it, these are all pebbles and most of the things. Artificial aggregates, um, uh, not used for RCC works. It is broken um, bricks bad suitable for mass concreting and foundations. Normally it is used for the foundations. Blast furnace slag, precast concrete products, fire resistance, but are responsible for corrosion due to sulfur content. So then, um, synthetic aggregate, it is thermally processed materials such as expanded clay and shale. This we can call it as a lightweight concrete. So all in aggregate, different fractions of fine and coarse sizes, they are not recommended for quality of the concrete. So then, graded aggregate. So aggregates, most of which passes through a particular size of sieve, are known as graded aggregate. Of course I already said that with a particular sieve it is going to pass and it is retained in between that sieves. You arrange the sieve from 0.75 micron to 4.75 and go on saving it, then you find out it how much you are going to get it. And normally that will use it for the soil also. Similar way we have to conduct it for the aggregates also. So then, graded aggregate of nominal size 20 means an aggregate of which passes through ISU of 20 See, normally, um, uh, if you say it is the size 20 means it is passing through the 20 sieve. That itself is one indication, or that's a formula we'll use it. 20 means it has to pass with 20 IS sieve. Then shape. So then, elongated aggregate, it is the length is of course 1.8 times or 9/5 of the its main dimensions. Flaky aggregates, it has lateral dimensions should be less than 0.6 times or 3/5 of the mean dimensions. Mean dimensions means average dimensions. If you take the average dimensions of the whole, then um, it should be less than 0.6 times or 3/5 of the mean dimensions. Then orient in one plane with water and air voids underneath, and adversely affect on the durability and are restricted to maximum of 15%. Normally it is restricted to 15%. Normally this flaky aggregates, that is the second statement. Normally if you keep it in the underneath, it will create the air voids because due to its shape of flakiness of this shape. In this figure you can see that it is a flaky aggregate and it is a elongated aggregate. Means in the flaky aggregate normally the surface dimensions are properly dressed. Next, if you can see that in the classification of normal weight, heavy weight and lightweight. In the normal weight, we can see that the specific gravity is varying from 2.5 to 2.7, and the unit weight that is in kilonewton per meter square, that is 23 to 26. If you are converting that into Newton, it will be 2300 to 2600 Newton per meter cube. Normally, if you see the density of the concrete, it is 2400 Newton per meter square. It has to satisfy. Of course, whenever if you design any of the concrete, make sure that it should follow the IS code, and it should come. The density of the concrete should come as 2400 Newton per meter cube. Then bulk density, if you calculate it, so it is 15.2 to 16.8. Best example is sand. So then heavy weight, so it is 2.82, specific gravity is 2.8 to 2.9, and its unit weight is varying from 25 to 29. So and its bulk density is varying from greater than 20.8. And even if you go for the lightweight, um, so lightweight the density is very less. You can specific gravity is around 2. You can make it as a 2 to 2.1, and the unit weight is roughly around 12 kilonewton per meter cube, and the bulk density is less than 11.2. The best example is dolomite. So normally even if you see here, the specific gravity as the weight of the aggregates is increasing, um, the specific gravity is also increasing. Means it has a directly proportional. Means as the density is increasing, the weight of its the material is also increasing. Of course, if you see the surface texture of in the classification, so glossy, the best example is black flint. Black flint is one type of material which can be used for the construction of the marbles. Smooth, of course, a gravel and marble. A granular is a sandstone. Rough basalt, crystalline granite, and honeycomb and porous, it is a brick and slag. Of course, there are different classifications. We'll move a little bit fast here. And good qualities of an ideal aggregate. What should be the good qualities of an ideal aggregate? An ideal aggregate used for the manufacture of concrete and mortar, and it should meet the following requirements. First one, it should consist of natural stones, gravel and sand, or in various combination of these materials. It should be hard, strong and durable. Of course, it should be hard, strong and durable. It should be dense, clear and free from any coatings. It is very important. It should not contain any coatings. It should be a natural one. It should be free from injurious vegetable matters, means organic matter. Normally what will happen is that if any organic matter is there, normally the degradation will happen with the help of the bacteria. When the decomposition or compose will start, composition or the decomposition will start, normally it will lose its weight as well as the strength as time progresses. That is why it should not contain any vegetable materials or any organic matters. and it should not contain any flaky and elongated pieces, and it should be like what graded sizes, not flaky and elongated pieces, because once you are doing it, it will consume lot of the sand as well as the cement when it is flaky and elongated pieces are there. It should not contain any material to attack steel reinforcement in case of reinforcement concrete, and you should be able to of course hmm, means when you this main thing is that best example is chloride attack on the steel. Suppose if any chloride content is there in the aggregate, or when you extract this aggregate from some of the rocks, sulfate bearing rocks or chloride bearing rocks, normally what will happen is that it consists of some chlorides. When this consists of this chloride, the chloride is going to react when you mix this aggregate in the concrete and along with the steel reinforcement, then normally what will happen is that immediately the corrosion will start. In that cases, your aggregate is responsible for the corrosion of the steel. That should not happen in this um, extent. This characteristics of aggregate we will discuss in the next class. Of course, many very important thing is that chloride attack and sulfate attack on the concrete has to be studied nowadays, and many people are not taking care of that, and most of the buildings um, um, uh, what is happening is that due to this chloride and sulfate attack, the strength is going to reduce, and major problem is that cracks are major problems in most of the buildings. If chloride content is there, uh, normally the strength of the steel is going to reduces as the time progresses. That should not happen in case of the concrete. Maybe this characteristics of aggregate we will cover it in the next class. Thank you.